In this problem, we are asked to confirm that the equation y equals 3e raised to the x cubed is a solution to the differential equation y prime equals 3x squared y, given the initial condition that y at 0 is equal to 3. It might be best to begin by substituting dy dx in place of y prime. We then need to separate our variables, the y's to the left and the x's to the right. We can multiply both sides by dx and then divide the y over, which gives us 1 over y dy is equal to 3x squared dx. Our next step is to take the antiderivative of both sides of the equation. We then want to anti-differentiate each side. Antiderivative of 1 over y dy is natural log absolute value of y. Antiderivative of 3x squared is simply x cubed plus c. From here, we can use our definition of a natural logarithm to rewrite this in terms of an exponential equation. That would give us the fact that e raised to x cubed plus c would have to equal absolute value of y. Thinking about how we could rewrite the left side, as we've talked about in other examples, we would have e to the x cubed times e to the c. E to the c, of course, can be written as a constant. I'm going to use the constant k. So we would have a constant k times e raised to the x cubed is equal to absolute value of y. We now can use our initial condition that we were given in order to find the k value. Remember, we were given that y of 0 is equal to 3. If we substitute these values in, we have e to the 0. On the right, absolute value of 3 simply is 3. E to the 0, of course, is 1. So we obtain a k value of 3. So what we end up with is that the absolute value of y is equal to 3e raised to the x cubed. Now remember, this was a problem in which we were asked to confirm that a given equation was a solution to this differential equation. The absolute value bars on the left can be eliminated because we know the initial condition begins with a positive value. And that's why we can eliminate them here in our final answer, thereby obtaining that equation we were asked to verify. If by chance this had been a negative 3, then our equation would have been a negative 3e to the x cubed. So you do need to take the lead when you're eliminating absolute value bars. Take your lead from what the initial condition is given to be.